There are several approaches to building a data lake platform. We will talk about one of the approaches that offer a high value to data scientists and analysts at a lower cost. In this integrated demo, you will see how different Oracle Cloud services work together to provide such a platform. These services include Oracle Object Storage, Oracle Data Flow, Oracle Data Catalog, Oracle Autonomous Database, and Oracle Data Science Platform. It assumes that the data has already been ingested using real-time streams or batch processes into a raw data store such as Oracle Object Storage. So first, let's go ahead and take a look at the data. Here's the mini data set that I'm working with. There are multiple files here with the patient data. Here's a CSV file and here's a text file that we will be working with. These files have been already ingested into the Oracle Object Storage. So let's go ahead and take a look at the object storage. I'm going to go to the Oracle Cloud Console, go to the Oracle Object Storage. Within the Oracle Object Storage, I have created a bucket, which is called Patient Test Bucket. The patient Test Bucket is going to have all the raw data. So let's go ahead and look at this data. I have multiple files in there in different formats. It could be any other formats as well. It could be Avro, JSON, as well as Parquet file here. I want to quickly take a look at one of these data files. We can click on the details, and here's the same data that I showed you earlier in a regular text file and a CSV file. So we should have all these data in here as well. So next thing we want to do is, now that we have the raw data in the Oracle Object Storage, we can process it, transform it, standardize it, or conform it. We will do that using the data flow service. To do that, I have written a Python script and uploaded it to another bucket. So let's go ahead and take a look at that bucket. So I'm going to go back out to the object storage. Here's a bucket I have created, which is called Spark Bucket. Within the Spark Bucket, I have a Python code. Here's that Python code. We can take a quick look at this Python code, and here it is. You can actually see this Python code here. It basically takes the raw data from patient test. It's going to conform it. It's going to transform it. And then it's going to write the output back out to another bucket called output bucket. So that's what this is going to do in terms of the functionality. We will run this Python code in the data flow service next. So let's go ahead and cancel out of here, and let's go to the Oracle Data Flow service to run this piece of code. So here's the data flow service. I'm going to go to the runs. I already previously ran this script already, so I'm just going to go ahead and say rerun here. When you rerun, or when you run this data flow jobs, it's going to ask you for your compute requirements. Please keep it in mind that data flow is a serverless service. What it means is that you only get charged per execution time. So you can specify your driver and executor shapes that you want to use for this specific job. Once you have done that, you can also specify different parameters. So here I have specified two parameters. This is my input file. So this is the file I'm going to process from my raw patient test bucket. And then here's the output file, which is going to be a Parquet file. And I'm going to write this Parquet file in a bucket called output bucket. So let's go ahead and run this job. I'm going to click on run. And now the job has been accepted. This is going to take about a minute or minute and a half to run. So while it's running, what I want to do is show you the Jupyter Notebook interface that can directly access the data from the Oracle Object Storage. So here's the Jupyter Notebook I have open. I have imported the OCI class in here to access the files from the Oracle Object Storage. So let's go ahead and run this piece of code. I'm going to run this piece of code. This tells me what observability domain I'm working with. Here you can see that I'm working with the patient test bucket. And within the patient test bucket, I'm actually going to access this file. This is one of the raw files that I'm going to be working with. So let's go ahead and click on that as well. So once I run this piece of block, it's giving me the same data from the files we have sitting in the patient test bucket. So this is a raw data set. Once you have this data into your Jupyter notebooks, you can pretty much do anything you want to do with it. So you can start building your model, whether it's a regression or classification and so forth. You can start building and working with the data right here in the Jupyter notebook. So now let's go back and quickly check on the progress of our job here. I'm going to go ahead and click on it. It's in progress. Where we do know that it's going to put it in the output bucket. So I'm going to go to the object storage at this point. And within the object storage, I have many different buckets. Some of the buckets you already seen. This is the raw data store. This is where we have the Python code that we ran with our data flow service. I also have some reference data like zip codes and so forth, which are residing in this bucket here. And finally, I want to show you one more bucket. This patient incident reports bucket has unstructured data. So it has the doctor's notes or incident reports and things like that in an unstructured format. So this kind of shows you all these different buckets I have. So let's go to our output bucket. Within the output bucket, we see there is a Parquet file in there now. So this is the file that was produced as a result of the data flow job that we just ran. So I want to quickly take a look at it. I'm going to go ahead and download this file. The file has been downloaded. And now I'm going to use the online Apache viewer to look at that file. So let's go ahead and open that file. Here's the file we just produced. Let's go ahead and open it. And take a look at it. So here's the patient data as we expected. And if you also notice that I have a new column in there, which basically kind of captures the time this file was processed. So the column has been added in there. So there are lots of transformations you can do in here. So with the data flow job, you can do transformations. You may interface with the external systems to grab a global ID, for example. You may add columns. You may reformat the data. There are lots of things the data flow job can do. Now that we have processed and confirmed the data, we need to catalog it. In the object storage, you will have lots of files, both raw and conformed. You need to search and discover data across different asset types, such as object storage, autonomous database, Hive, and more. This is where Oracle Data Catalog Service comes in. Not only it helps you find the data, but it can help you tag the data as well as build business glossaries. Basically, the catalog prevents your data lake from becoming a data swamp. So let's go ahead and take a look at the data catalog service. So let's go back to the console again. This time we're going to select the data catalog service. In the data catalog service, I already have built a catalog, so let's go ahead and take a look at that. Within this catalog, as you can see, there are multiple asset types here. So this one is the object storage. These two are autonomous databases. And now I can search across all these different asset types. So I'm going to go ahead and just search for patient and see what it comes back with. It's coming back with lots of data. Some data residing in the object storage, as you can see, some data residing in the autonomous database, and so forth. So let me go ahead and filter this out. So I can go here and just filter it out. And as you can see, there are many different asset types like object storage, Oracle database, MySQL, Hive, Kafka, and so forth. In our case, we're interested in the object storage. So I'm going to go ahead and filter it out by the object storage. I'm also going to change this a little bit. I'm going to say instead of patient, I'm going to say patient ID here and see what I get back. So there are 4 references of patient ID information within my data catalog. Let's go and take a look at one of these because this says column 0. I'm not sure what that is. I'm not sure why it selected this column as a patient ID column. So let's go and take a look at that. So when I do, I just realized that this is one of the raw files that we have ingested in our object storage. And the first column apparently is the patient ID. And if you scroll down a little bit, you can actually see a tag there that this is a patient ID from the source system. So it's helping me allocate what the raw patient ID look like and where they reside within the object storage. Next thing what I want to do is go back to the assets here. And within the data assets, I'm going to go back to the patient lake again. I want to quickly show you how to harvest the data. Harvesting is very simple. I already have a connection to the object storage itself, so I don't really need to do anything there, but I can simply click on harvest here and walk through these steps here. If I'm harvesting from the object storage, you're going to see the same object storage buckets as you saw earlier. So I can just add these bucket here, and once I add this bucket here, I can create a job. And this job will basically harvest the data from that bucket itself. So we just produced that Parquet file at the end of the data flow job, so we can basically harvest that file and see what the data looks like. So I'm going to go back to our search again. Let's look at the other entities here. So for example, we have patient ID here. I'm going to go take a look at this. So when you look at this patient ID, this actually belongs to the Parquet file we just produced a few minutes ago. And it also has a column called patient ID. So, and if I scroll down over here, it's saying this patient ID is actually a conformed global patient ID. So this must be a little bit different and reformatted, or the global ID that I produced during my data flow job. Another way to look at all this data is you can go back to your assets. You can look at the asset itself, and you can click on data entities. When you click on data entities, as you can see, there are some entities that belong to the output bucket. This is our conformed bucket, and some of the other data or entities belong to the patient test. So patient test is our raw bucket. So you can clearly see the difference between where the data resides. You can also manage the security on top of these buckets. So you have a set of users. You can basically say this set of users can only access the output bucket or just the patient test bucket or both. So you can manage the security, you can tag the data, you can view these different entities in different stages or life cycle of the data itself. So now that we have seen the ability to catalog the data and search and find and discover the data, you can also build the glossaries here. You can do a lot of things with the data. Now it's time to access the data itself. So let's talk about accessing the data from the object store with SQL interface first. For that, we will use Autonomous Database as the processing layer. Please make a note, for high concurrency and performance, you may need to move the data from the Oracle Object Storage to Autonomous Database. To look at the SQL interface, I'm going to go to SQL Developer here. And in the SQL Developer, I'm going to run this query here. This query basically says select all from patient external table. So it is actually running on top of an external table. This external table was created on top of the object storage bucket we have. So here's the output, as you can see, but this output is actually generated from the data residing on the bucket itself, the patient test bucket. I want to quickly show you how to create those external tables. This is a PL SQL block. Within this PL SQL block, I'm specifying here's my table name, and here's the URL. This is the object storage. Here's my bucket itself, and the star basically indicates all the files within the bucket. And that's the reason behind I have two files over here. I have two different data files or three files ingested, so that when you actually search or query against this bucket, I wanted to make sure that it's actually pulling the results from all these files I have residing in the bucket. So it should bring back, let's say, this Sam Shah record from this file, as well as Ralph Doe record from this file. So if you go back to our query results set, we have Sam Shah in there as well, and we should have Ralph Doe as well. So it's basically pulling this query and returning the results across multiple files we have residing in the bucket itself. Next thing I want to show you is that I have an internal or local table to Autonomous Database, which is called patient visits. I have this table. I'm going to run the query against it just to take a look at the execution plan of it. So when I click on this button, it's going to show me how the query was executed. As you can see, that it's using a results cache. Using the results cache, it can produce the response times that are much, much faster. But this is coming directly from the Autonomous Database. It's not going to the Oracle Object Storage. So the first query was going against the Oracle Object Storage. The second one was actually going against the local table. And we're going to be combining these two tables again and see what it's going to look like. Next thing I want to do is query two external tables. So as you can see here, there's a patient external table. There's also a zip table. This is also an external table. So I wanted to combine these two tables and join these two tables. So let's go ahead and run this query. When you run this query itself, it's going to show the same result set, but now it has a township or the city assigned to that specific zip code. Next thing I wanted to do was combine and join the data from two tables, where one table actually is an external table. This is our patient external table. And the other table is an internal local table, which is the patient visits table. And I'm going to join these two tables on a specific patient ID. So let's go ahead and run that. This is going to probably bring back a record of this patient's visit. As you can see, Ralph visited a doctor on this date, visited this doctor here. And then you can also see a URL here that kind of points to the incident report or a doctor's note. So this is a nice way to kind of link your structured and unstructured data together. By using this URL, you can easily access the full report. Next thing I wanted to do is get total visits by different zip codes. So that's where I have this query here. I want to get total visits for this specific zip code. This is a zip code in Brooklyn, which is 11232. So let's go ahead and run this query and see what the result looks like. It's giving you back 27 visits in this zip code in total, which is great. But let me look at the execution plan. When you look at the execution plan, it's saying materialized view rewrite access. So basically, it took my query and it rewrote the query to go against a materialized view. And this is the materialized view it's using. So I have created a materialized view over here, which basically aggregates number of visits by different zip codes. So that has been already created. And now using the automated query rewrite capability, instead of this query running against the object storage, it was able to run it against the materialized view to give me a much better, faster response time. So this is very useful, where you can take some of this data, you can summarize and aggregate the data and keep it within the materialized view or within the autonomous database, where the detailed information can still reside on the object storage level or within the files within the object storage. So it's a nice capability to get a much better response. Second thing I have done is I just have a simple query where I want to select distinct zip codes from the patient external table. And as you can see in both cases, in both queries, we are querying not the materialized view, but we are querying the external table. So let's go ahead and run this query. We should get back different zip codes in there, and there they are. And if you again look at the execution plan, within the execution plan, it has been doing query rewrite for me automatically. So instead of going down to the external tables and looking at the data from the object storage, it went to the materialized view to get me the different distinct zip codes. So this could be very effective. There are a couple of other good features to help you with the performance from the Oracle Object Storage external tables. One is called external partition data, and the other one is called hybrid partition table. With the external partition data, you basically have this feature basically queries only the relevant data files in the object storage. Hence, it's kind of performing the partition elimination. With the hybrid partition table, I can create some partitions of my data which can reside on the object storage. The other partitions can reside within the autonomous database. So this is a nice way to get like multi-tiering for your queries, where hot data resides within the autonomous database locally, and you have the cold data which kind of resides on the object storage in different partitions. So there are many features here that can help you gain better performance. Now that we have seen the SQL interface running on top of the Oracle Object Storage, we want to talk about the Oracle Data Science Service. The Oracle Data Science Service is an enterprise-grade service where teams of data scientists can collaborate to build, train, and deploy machine learning models. It supports latest open source tools, version control, and has tight integration with Oracle Cloud Infrastructure. So let's go ahead and take a look at that. I already have created a project within the data science service, and within the project, I have already opened up a notebook. Within this notebook, again, I have all these import statements to bring all these libraries in. Next, you will see that I'm accessing the patient test bucket and one of the files in there, which is called sample object CSV file. So let's go ahead and read this file. It's going to read this file and it's done. Next thing I want to do is kind of show top 5 rows. I'm going to go ahead and run this. So it's showing me the top 5 rows. Yeah, this is not the data that I was expecting. I mean, with the decimal points in patient ID and visits and so forth. So in the next step, I need to do a lot of cleanups and wrangling, as well as I can start building my model as well. So I wanted to, for example, model it in such a way so that depending on their doctor visits and depending on their age, you may want to predict their lifespan. So you can do all of that once you have this data. So I'm going to go ahead and run this piece of block here. Let's run this. And I have a new data set now. So in this data set, I have different patient IDs, as you can see. You also have lifespan column that kind of projects what their lifespan is going to look like based on the visits and age and so forth. And the last thing I want to do is write this data back. I want to write this data back to the object storage to save it so others can work with it. And here I wanted to save this as a JSON file. So let's go ahead and run this. In the next step, you can actually see that it's going to save the output into the output bucket again. But this time it's going to save this as a JSON format. So this kind of makes it very interesting that you have data that where you started with, it was in a text file and a CSV files, then we converted it into Parquet file. Now we're working with the same data set, but this time we're going to save this as a JSON file. And this will basically run it, and it creates a file here, which is called JSON file itself. So let's go to our object storage. I'm going to quickly go to our object storage and see if those files are there. Here's my object storage. And within the object storage, here's the output bucket. And I think I need to run one more piece of code here. So let me go ahead and run it. Okay, it basically ran it. By the way, as you can see, you can also see show in notebook. I can show the output in a different way as well, where you can see the features, you can see the correlations, and other things within the notebook as well. So here's a summary of the data, here's the actual data, and so forth. So let's go back to our output here. We should have that output now in a JSON format. And here it is. So I'm going to go ahead and download this file here. Now that we have the file downloaded, I'm going to go ahead and open it. I'm going to open it with the text edit tool. And let's go ahead and take a look at it now. So here's the final output. This is where I have all the patient information as well as their lifespan predicted using my machine learning model. So as you can see in the journey, we started with these raw data files. We took these data files, we processed it with Oracle Data Flow Service. Once we processed it, we created a data catalog. We extracted the metadata and created this catalog so that we can easily search and find the data and define the data. And then in various ways, we were able to access this data. We access this data using a SQL interface. In our case, we use Autonomous Database as a processing layer. We also use the data science service to access the same data and build our model. And finally, we also use Jupyter Notebooks to access the data and build